So how do we do this stuff? You'll notice that on this page you've got sine. On the next page you'll have cosine, and then on the third page you have a mix. So let me go ahead and I'm going to do a couple off of each page except the third. So I'll do two. I'll do the first two off of the sine page, and then I'll do these two off of the cosine. All right. So I think what I did is I picked the two. There's four translations. Two of them are the easiest, and I want to do the easiest ones today. All right. So we've got something called amplitude, and then you've got something called vertical shift. All right. So let's go ahead and actually take care of this piece right here. You'll notice that the difference between these two is you've got a number attached to the front, and then you have a number attached on the back. Now, if it's attached on the back, it could also be negative as well. Okay, it could be negative. This just means that it would drop down. This means it's going to go up. Okay, this amplitude is something different altogether. So let's see how this works. Let's do the amplitude first. All right, and what it wants me to do is graph sine, and I will graph this change in the amplitude. So let's graph sine. Now, what I'm going to do is I'm going to go about half. Let's see, I'm going to go 1, 2, 3, 4. Okay, so every 2, I'm going top 4. So every 2, I'm going 1 unit. Okay, so we're going all the way to positive 4, all the way to negative 4. So if I were to graph sine normally, the way that he looked back from our notes was that he starts at 0, he ends at 0. He also, halfway through his cycle, he also hits 0 again. And then once he reached pi over 2 at 90 degrees, he went to his highest. And then at 3 pi over 2, he went to his lowest. All right. So here's a mini graph here of sine. All right. And that just takes care of this piece. Okay. Now what this is going to do is it's going to allow us to actually see the effects of the amplitude now on a regular old sine. If I have a 4 in front, okay, this thing is called the amplitude. Okay, now if this thing was negative, I would actually be going in the opposite direction, but I'll worry about that when I talk about cosine. All right, so just a second. So now what happens though is that an amplitude is a little unique in that it actually climbs all the way up to 4 at its highest point, and then at its lowest point it will go all the way to negative 4. So it continues the same basic cycle with your zeros remaining at 0. Okay, because those are like its anchor points. But its max used to be at 1, but now because of the 4, it's going to go all the way to 4. Okay, instead of negative 1 here, you're going to go to negative 4 there. All right. Now what this does, it essentially keeps you 0, 0. Okay, but you're going to climb all the way up just like this. All right. Okay, so that is the effect of an amplitude. Okay, now if this 4 would have been negative, then I wouldn't have gone to positive 4 first. I actually would have gone to negative 4 first. And then instead of negative 4 here, I would have went to positive 4 here. So the whole thing would have basically reversed its orientation. Okay, and he'll show up when I do the cosine. All right, but that's an amplitude shift. And this would be the equivalent in music. If you took a wave and changed its amplitude, that would basically be changing the volume. Okay, you would just make it louder. All right. Now let's see what this does here. This is called a vertical translation. So let's do that. Okay, vertical translation. All right, or a vertical shift. All right. And what will happen with this guy is a little bit, well, it's different, right? Here's your sine. All right, let's go every 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Okay. Pause. I don't go 3. Go 2. 1, 2, 3, 4. Negative 1, negative 2, negative 3, negative 4. All right, so now a sine would just look like this. Here, goes up to the top, comes back down, goes down, and comes back up. This is sine. Okay, this is its normal curve right here. Okay, now we're about to graph this on top. What happens then is that every single one of these values gets added by 2, not multiplied over here. The 0 times 4 stayed 0. That's why these anchor points stayed 0. But over here, every single one of these will get added to, even the zeros. So what this means then is that this guy has what's called a midline at positive 2. So at positive 2, we draw a dotted line. The whole thing has been lifted. Okay. Now, because I'm lifting the whole thing, the maximum value here is not going to be 1 anymore. He'll actually be 3 because I'm adding 2 to it. So a way to look at this is that you basically just recreate the sine pattern, but instead of doing it on the x-axis, you're going to do it on the y equals 2. Okay, because the whole thing is lifted up. So here he goes up, then he hits 0, he comes down, and then he goes back here. Okay, so your final answer is that. Okay, the whole thing has been lifted, and that is a vertical shift. Okay.